So let's take a look at our notation for functions. So how I would read this is y equals f of x. So what we're getting out here, so y represents the output of our function, while x represents the input of our function. And then f is the name of our function. So when we start working with multiple functions, we might have function f, g, h. So then if I was asked to find like h of, and then some number, let's say 3, the letter out front lets me know which function to use as the structure for plugging in the x value and getting the output. So with our function notation, we're going to look at inputting values and calculating. What we'll also look at is plugging in a y value and solving for x. But what it'll translate to is with these functions and in this notation, we can see coordinates coming through. So we'll have this function f that we can graph, and we can graph it by choosing various inputs to plug in and get their various outputs and translate them into coordinates. So let's get some practice with this function notation and plugging in and reading it. So in this first example here, we have this function f of x is equal to 4x plus 5, and we want to find f of 2. So what this function notation gives me is this structure and this kind of operation that I want to follow. For whatever I input, I want to take 4 times that input plus 5. So sometimes how I imagine this is just with empty parentheses. So if I had f of nothing, what I would do is take 4 times whatever was in there plus 5. And then how I'm going to use this function notation is whatever I plug in to that function notation, f of whatever, I plug in that same exact thing into the parentheses there. If I, for whatever reason, plug in an elephant, I'm taking 4 times the elephant plus 5. So whatever goes in the parentheses for f is what goes into the parentheses where x is in the general structure. So in this case, I'm plugging in positive 2. So because I want to plug in 2, then where I had x before, I'm plugging in 2. Again, when plugging in values, right here it's not too bad, but in the future it's just good to have a habit of using parentheses because it'll help with order of operations and calculating things correctly. So with this, I'm going to simplify this right-hand side. So 4 times 2 is 8, and then I have this plus 5, and that's 13. So I end up with this answer that f of 2 equals 13. Something that students sometimes do here, and it is from the habit of using parentheses to represent multiplication. Sometimes students think of this notation with f as like a variable f times 2, but think of this as kind of a full notation. Whenever you have that letter f or whatever your function notation is, you need those parentheses with a number next to it to show what your input for the function is. So that notation f of 2, we can't break that up at all. That's totally simplified. So don't do anything like dividing by 2 at this point. And if you've never thought about doing this, just totally ignore it and never think about it. But it's just something that comes up with this new notation. But think of these as a structure that have to go together. So f of 2 equals 13. What this is telling me is 2 is my x value and 13 is my y value. So I can see my function input and function output. And with that, if I wanted to start graphing this function f, this gives me the coordinate where x is 2 and y is positive 13. So with this function notation, where you can clearly see input output, you can translate it to a point. All right, with this next one, same idea. Now we're working with this function g of x. So if I want to find anything, oh, and I even made a mistake here. Notice how I used f here? Okay, I'm going to change it to g. But just to make a point that I was mentioning earlier, technically what we should do is take this and use our function f that we defined over here, since we're kind of in the same problem. We're not going to do that because I want us to use this function g of x, but my typo could have led to a totally different calculation, that since it's asking for f of something, we should use our function f. However, I want to use g of x, and I just made a typo, so I'm going to switch that to g of negative 3. All right, so g of x. If I think about this as a structure, we're going to have our input, and what we would do is take our input squared. Again, those parentheses are going to be really important here. And then minus 2 times our input, and then plus 6. Now for us, we're plugging in negative 3, so I want to have negative 3 in those parentheses. And then we're just going to simplify. So negative 3 squared, and this is where the parentheses are super important, because if we didn't have them, we'd get negative 9, but this should simplify to positive 9. And then negative 2 times negative 3 is positive 6, and then we have a plus 6, which will be a 15 plus 6, which is 21. So we get a solution that g of negative 3 is 21. And if we wanted to, we could write this as a coordinate and graph it, where x is negative 3 and y is positive 21. So these two cases here are the idea of having our function and inputting a value into the function, and when we do that, we should only have one output. If you get to the end here, and like where we ended up with 13, and somehow you ended up with 2 solutions, that can't happen here. Same thing with g of x, where we got 21. If you ended up with more than one solution, something went wrong. Because if these are using function notation, they should operate as functions, where for each input, there's just one output. Now, in these next examples, what we're being told is basically our y value. This notation where it says solve h of x equals 20, we're being given what y is. Y is 20, and we want to find x. So what I would do here is they're telling me h of x is the same thing as 20, so where I see my notation h of x in my formula of 2x minus 8, I'm just going to plug in 20. So I'm going to replace h of x with 20, and then I know that that equals 2x minus 8. And then I'm going to solve for x. So I'm going to add 8 to both sides, divide by 2, and that'll give us x equals 14. So what I could do is write this in function notation by taking this 14 and having it represent x. So we know that h of 14 equals 20. And if we wanted to write that as a coordinate, we'd have x equals 14 with an output of 20. So that's the difference between these two ways of working with our functions. I mean, there's many different ways we can work with our functions, but in this video, the idea of being given x and solving for y versus being given y and solving for x. Let's look at another case here. So f of x is equal to 5. So I want to plug in 5 for f of x equals x squared plus 4. Now I'm going to solve for x, so I'll subtract 4 from both sides. I'm going to take the square root of both sides, so I get x all alone. And when we do that, taking the square root of both sides, we'll get plus or minus, and square root of 1 is 1. So notice here that I actually end up with 2 solutions. X could be positive 1, and x could be negative 1. So in my function notation, how I would write that is f of 1 equals positive 5, f of negative 1 equals positive 5. Or another way would be to write it as the1, 5, negative 1, 5. Now, as I mentioned up above here, in these questions up above, we should only be getting one solution. We plug in our input, we get a single output. However, this is okay because it's the idea that we can have the same y values as long as the x values are different. We have different inputs here, and even though it's the same output, that's totally fine. So if you think about the last video where we looked at the coordinates and the tables and the graphs, this works as a function because the x values are different. So when working with the solve case and being given the function output, you can end up with more than one solution. But when you plug in a value for x and solve for y, you should definitely only have one solution.